Hi, welcome to another edition of Engineering with Lego Bricks and Robolab. I'm Eric Wong, and I'll be your host. Okay, let's talk about forks really quickly. So I've got the basic skeleton of a program here for building basically a line follower. So I want it to say if it's seeing a light patch in the ground, turn one way. If it's seeing a dark patch in the ground, turn another way. So I could do, for example, line follower. So turning right, turning A on and C off typically would turn right, and vice versa. Turning A off and turning C on will typically turn left. So I want to do one or the other, and the way you do that is with a fork. It's called a conditional. So I go under forks, and here we go. So I can fork based on touch sensors, temperature sensors, containers, all kinds of stuff. I'm going to use a light sensor because that's typical what you'd use for a line follower. And so let's basically ask the question, is the light sensor value greater than a certain value? If it is, turn right. If it's not, turn left. So that's all we need there. So I'm going to wire this guy in. Oops, so wire that guy in there. All right. And notice this is a unique kind of icon because there are three pink wires coming out of it, because it's either going to do one or the other. You can't do both at the same time. You can never do that. It's going to do one or the other. And here's a fork. I'm going to put this in there, and I'm going to have to merge these back down there because after these two conditions are done, I have to go back to doing one thing at a time. So it's doing one of these two and then continue on doing my stuff. All right. So I need one more thing for this program, and that's to set that light sensor value. So I'm going to come in here and I'm going to say if it's greater than 35, for example. Okay, so now my program's ready to go. I can go ahead and read this. So if the light sensor value is greater than 35, it's going to turn right, and then continue on and loop back. If it's less than or equal to 35, it's going to turn left. So this will basically be a generic kind of line follower. Now the only tricky thing about this, which actually has to do with loops as well as forks, is the way I've done this program won't quite work the way I want it to, because this is going to loop 50 times. And you can think about that. That's going to make, some people think it's going to make 50 turns, like left, right, left, right, left, right, 50 times. That's not the way it's going to work. Let's look at this a little more carefully. So I start, it says loop 50 times. Is the light sensor greater than 35? Let's say it is. It'll go through. Let's say you're seeing a piece of white, bright flooring or white tile or something, and it sees greater than 35. It turns right. Okay, now it's currently turning right, and it'll loop back around, and it'll ask the question again, is it greater than 35? Well, you might still be on the white, so sure. And if you continue on the white, for example, this looping, because there's no wait fors or anything else, basically will run. It'll only take 4 or 5 milliseconds to run this fork here, this loop. So this whole thing will be done in a second or two. It won't get 50 turns. Typically, actually, you only get 1 or 2 because it loops so fast, the robot has barely even moved by the time it takes another light sensor reading. So take a light sensor reading, take a light sensor reading, take a light sensor reading. It goes very, very quickly. So chances are this is not the way you want to do it. So you want to look at the little tutorial on looping to see how you probably want to loop for time, for example, would be a better one, instead of looping for a given number of loops.